We're going to be moving on to vectors in section 8-4, and the big thing you need to remember is when you have a vector, you have a starting point, which is called an initial point, and then you also have an end point. So a vector is an array, and the arrow part of the vector is the end point of it. Each vector has a magnitude, which is also known as the length of the vector. So if you wanted to find the length of this vector, what you would do is you would go ahead and you'd say up 3 and you'd go over 4. So you could use the Pythagorean theorem to find the length of the vector, or 3 squared plus 4 squared is equal to the hypotenuse squared. And if you were to solve that, you get x is equal to 5, or the magnitude is equal to 5, and the magnitude is just its length. We also have direction or bearing of a vector. And when we start navigation, I'm going to be using bearing or heading as the direction of the vector. And it's always measured clockwise from north. So if I were to go ahead and draw a set of axes, 0 degrees is actually starting at where north is, and then this would be northeast, southwest. So this would be 0 degrees. Then when you go east, that would be 90. South is a direct 180 degree bearing, and west is 270 degrees. So in this example, if I were to draw a vector that made a 10 degree angle with the x-axis, and I wanted you to tell me what its bearing was, what you're going to go ahead and do is you're going to start from north. North is your starting point, and you're going to go ahead and figure out what its bearing is. So if you remember, this was 0, this was 90, 180, and 270. The bearing would just be 270 degrees plus that 10 degrees, or it'd be a 200 degree bearing vector. Sometimes you're going to actually not even have a diagram, and they'll just say, okay, it has a southeast bearing. So you do have to know north is here, east, southwest. I always remember is never eat shredded wheat or never eat soggy waffles starting at north. If they just say it's southeast, you can assume that it's a 45 degree bearing. It's a perfect southeast. So you're going to go ahead and measure it from north. So the bearing on this one would just be the 90 from north to east. And then you'd go ahead and add on that 45. And that would just be a 135 degree bearing. So you could say southeast is exactly 135. So in this last example dealing with bearing, you would have to find what the bearing was of this vector, remember measured from north to here. So you can say that if I can find this angle right in here, and I were to make a nice little right triangle so I could find the edges of this right triangle, I could take the 270 degree bearing, which would be a west bearing, and I could go ahead and I could subtract off whatever that angle is. So if I find that angle, I'm going to get the bearing. So I can just count. Right here the distance is 3 and this distance is 4. And so I can just use the Pythagorean theorem, so it's a 3, 4, 5 triangle. And so now what I can do is I can go ahead and find that angle. And I didn't even need to know that that was 5. But I could go ahead and find that angle by just doing tan inverse of, now remember tangent is opposite of over adjacent, so it's tan inverse of 4/3. I have to use my calculator to get that because it's not on the unit circle. So I know that that's a 53.1 degree bearing, so I just say it's 270 minus 53.1, or I'd say the bearing is 216.9 degrees. So some vocabulary is equivalent vectors, and equivalent vectors are vectors that have the same magnitude. Remember, magnitude was a fancy word for length, and they also have the same direction. And remember, that was this is just a simplified word for bearing or heading. So we're going to be using those words interchangeably. Magnitude, length mean the same thing. Direction means bearing or heading. So if I have this vector with a starting point right here, then what I can go ahead and do is if I go over 1 and down 3, I draw a vector, and I call that vector B. And usually vectors have this little arrow on the top of it to denote it's a vector. I would say that another equivalent vector would be the same deal. It would have a starting point. I would go over 1 and down 3. And so these two, if this is vector A is equivalent to vector B because they have the same direction. So notice that they would have the same bearing and they have the same length. And so if you kind of look at it, they're parallel. All right, so we're going to be talking about adding vectors. And when you add them, you're going to be adding them from head to tail. So here's what I mean by that. So let's say you have vector B with this starting point and you go over 1 and this time let's go down 4. You always have a horizontal and a vertical component. I'm going to call this vector B. And let's say vector A starts here and I go up 2 over 3. And this is vector B and you have that little arrow above it. So if I want to find vector A plus vector B, what I do is I start with the first vector right here. I'm going to draw vector A. Oops, this was supposed to be vector A. Sorry about that. So I'm going to draw vector A. I'm going to start with that. So I'm going to go up 2 and then over 3 from that starting point. I'm going to label it as A. So you always start with the first thing here. And then to the end of that, so this is like, this is the head of the vector where the arrow is, and this is the tail. So I'm going to go ahead and start right here. And I'm going to start B right at that point. So B was over 1 and down 4, so I'm going to go over 1 and down 4, so I'm going to end here. I'm going to go ahead and put my B. And then the result is going to be where you initially started, so right here, and then end it at B. So this would be the result of A plus B. So if I were to draw the result of vector B plus vector A, it would be a little bit different. I would start off with vector B. Remember, you got to start off with this. So vector B was go over 1 and down 4. So I would go ahead and draw vector B. And then at the end of that one, so right here at the tail of that, I'm going to go ahead and draw in vector A. So I'm going to go up 2 and then over 3 from that point, and I'm going to go ahead and draw vector A. And then the result would be where you initially started all the way to the end of that. So this would be B plus A. And if you notice right here, if you look at these two vectors, A plus B, see how they have the same length. How I know that is from here I go over 1, 2, 3, 4, down 2. This is over 1, 2, 3, 4, down 2. They have the same magnitude and they also have the same direction. So these are called equivalent vectors. So it doesn't matter the order that you end up adding the two, the result is still the same, but the diagrams do look a little bit different because you go head to tail.